Solution center steps. Learn. Okay, we're in the learn section. Navigate through an interactive diagram of the solution's architecture. Watch videos about the AWS services related to the solution. 2. Plan the section you will. Review a breakdown of your building tasks. In practice, you will build a portion of the solution using a step-by-step guide. Review important concepts related to each guided step. 4. In the DIY section, you will complete the solution independently to reinforce what you've learned. Validate your completed solution. Cool. They basically give you the lesson plan up front. Alright. We're getting a bit more into how we're going to map out all the different services and resources. This is the learn section. Here you can interact with a diagram of the solution you will build. These navigation buttons cycle through the solution diagram to explain how it works. This is step 1. Click the arrow on the right to move to the next step. The static web page hosted on Amazon S3 is configured to show the daily predictions of beach wave sizes. Files that support the web page's functionality, such as client-side scripts and style sheets, are stored inside an S3 bucket together with an HTML file. Cool. Each day, a file that contains the hourly wave size prediction is sent by the island's IT department to an S3 bucket. So let's just say this is pretty basic at the moment. It seems like they have to physically send this, which is not ideal. You'd want this to be automated, but maybe they will automate it on their end. Visitors to the island web portal triggers a GET request from the island portal to the waves. Okay. So that's the island portal to the waves HTML page, hosted on Amazon S3 to display the forecast data. So they come here and it says get the HTTP get. You're getting this waves.html file. Here it is down here. So that's going to there. Hosted on Amazon S3 to display the forecast data. Yep. Great, you've reached the last step. Click the video concepts icon to view the video list. Alright. Cool. And now choose a video.
Amazon S3 overview.
Alright.
Amazon Simple Storage Service. Amazon S3 is an object storage service. An object consists of data and metadata. The metadata is a set of name-value pairs that describe the object. Buckets are containers for objects stored in S3. An object is uniquely identified within a bucket by a key. The object named photo/puppy.jpg is stored in the John Smith bucket, and it is addressable using this URL: http://johnsmith.s3.region.amazonaws.com/photos/puppy.jpg. Amazon S3 offers industry-leading scalability, data availability, security and performance. Customers of all sizes and industries can use it to store and protect any amount of data for a range of use cases, such as websites, mobile applications, backup and restore, archive, enterprise applications, IoT devices and big data analytics. Amazon S3 offers industry-leading performance, scalability, availability, and durability. It can easily meet fluctuating demands by automatically scaling your storage resources up and down without upfront investments or resource procurement cycles. Amazon S3 is designed for 11 nines of data durability, because it automatically creates and stores copies of all S3 objects across multiple systems. This means your data is available when needed and protected against failures, errors, and threats. Amazon S3 also offers unmatched security, compliance, and audit capabilities. It secures your data from unauthorized access with encryption features and access management tools. S3 is the only object storage service that allows you to block public access to all of your objects at the bucket or the account level with S3 Block Public Access. You should enable block public access for all accounts and buckets that you do not want publicly accessible. S3 maintains compliance programs, such as PCI DSS, HIPAA High-Tech, FedRAMP, E-Data Protection Directive and FISMA, to help you meet regulatory requirements. AWS also supports numerous auditing capabilities to monitor access requests to your S3 resources. Amazon S3 is the most supported cloud storage service. You can choose to work with a partner from the AWS Partner Network (APN), which is the largest community of technology and consulting cloud services providers. The migration partners can help you to transfer data to Amazon S3. The storage partners offer S3 integrated solutions for primary storage, backup and restore, archive and disaster recovery. You can also purchase an AWS integrated solution directly from the AWS Marketplace, which lists over 250 storage-specific offerings.
Cool. Seems more in line with the sales pitch of it rather than learning to use it. Not sure if
Amazon Simple Storage Service, Amazon S3, Performance. Amazon S3 is an object storage service that offers industry-leading performance. It supports parallel requests, which means you can scale your S3 performance by the factor of your compute cluster without making any customizations to your application. S3 performance scales per prefix. But what is a prefix? Let me give you an example to explain. Amazon S3 supports the folder concept as a means of grouping objects. For example, if you have an object, a photo called myphoto.jpg, stored in photo/myphoto.jpg in a S3 bucket, the prefix in this case is photo/. If you want to list all the objects in the photos folder, you can send a list request, which specifies the prefix photo/. Amazon S3 performance supports at least 3,500 requests per second, including put, copy, post and delete requests, and 5,500 requests per second for get or head requests. For example, if you create 10 prefixes in an Amazon S3 bucket to parallelize reads, you could increase your read performance by 10 times to 55,000 read requests per second. There are no limits to the number of prefixes, so you can use as many prefixes as you need in parallel to achieve the required throughput. Now, let's look at S3 consistency. Amazon S3 delivers strong read after write consistency automatically for all applications. There is no impact to the performance or availability. Strong consistency applies to all existing and new S3 objects, works in all regions, and is available to you at no additional cost. With strong consistency, S3 simplifies the migration of on-premises analytics workloads by removing the need to make changes to applications, and reduces costs by removing the need for extra infrastructure to provide strong consistency. All requests for S3 storage are strongly consistent, including S3 get, put, and list requests, as well as operations that change object tags, access control lists ACLs, or metadata. With strong consistency, what you write is what you will read. After a successful write of a new object, or an override of an existing object, any subsequent read request immediately receives the latest version of the object. That means you can also immediately perform a listing of the objects in a bucket with any changes reflected. Because of this, strong consistency is great for data lakes, which require access to the most recent data immediately after a write.
interesting things in there, like how they automatically parallelize the reads through the different folders. This bit here. Because usually, if you're thinking about this as one SSD, which I would be thinking about it, even if you're grabbing things from different folders, you would think that I'll grab one, then grab the next one. But it seems to be able to do this, each of the different folders separately and parallel. I don't know if this is, it says no limits here. I don't know if this is, you can only parallelize up to 10, I'm not sure. Here it says no limits. Cool, that's interesting.
Amazon Simple Storage Service Amazon S3. Access Management. By default, all Amazon S3 resources, such as buckets and objects, are private. Only the resource owner, an AWS account that created it, can access the resource. The resource owner can optionally grant access permissions to others by writing an access policy. Amazon S3 offers access policy options that can be broadly categorized as resource-based policies and user policies. Resource-based policies are access policies that you attach to your resources, such as buckets and objects. Bucket policies and access control lists, ACLs, are resource-based policies. You can also authenticate certain types of data access using query string authentication to grant temporary access to others with time-limited URLs. User policies are access policies that you attach to users. Access can be granted to users using AWS IAM policies. You may choose to use resource-based policies, user policies, or some combination of these to manage permissions to your Amazon S3 resources. Access control list is a legacy access control mechanism. As a general rule, AWS recommends using S3 bucket policies or IAM policies for access control. When Amazon S3 receives a request, it must evaluate all the access policies to determine whether to authorize or deny the request. First, let's look at resource-based policies. Access control lists. Each bucket and object have an access control list, an ACL, associated with it. Access control lists use Amazon S3 specific XML schema. It defines which AWS accounts or groups are granted access and the type of access they have. When you create a bucket or an object, Amazon S3 creates a default ACL that grants the resource owner full control over the resource. You can use access control lists to grant basic read-write permissions to other AWS accounts. Bucket policy, written in JSON, is attached to a S3 bucket. It provides access permissions to the S3 bucket and all objects in it. Here is an example of a S3 bucket policy. This S3 bucket policy allows the principal, the root account and the IAM user Alice under that account to perform any S3 operation. The wildcard asterisk character after the S3 in the action statement indicates that all S3 operations are allowed. Particularly, you can perform S3 operations only on specific resources, as shown in the resource statement. In this case, only the S3 bucket with name my bucket and all objects in it are allowed. As you can see, you can use the slash and asterisk after the bucket name to indicate all objects in the bucket. User policies.
That's going to be really important for an app where there's multiple users and having data protection in place to protect each individual user's assets. So I don't know if you would have like a different bucket for each user created, and then for each user you would have a certain access policy for that bucket that only allows that user to get their information. Or you'll have like the one bucket, and then for each individual resource you'll give permission to the specific user to access their own resource. I imagine having the bucket, an individual bucket for each user, may provide like a higher level of protection, but I'm not sure. It might be the same level. And I don't know if having an individual bucket for each user becomes hard to manage. We'll have to investigate more on this, but this is good. This is like what we want to be learning about.
After the bucket name to indicate all objects in the bucket. User policies control who has access to your Amazon S3 resources and is written in JSON. You can use AWS Identity and Access Management, AWS IAM, to create users, groups, and roles in your account and attach access policies to grant them access to Amazon S3.
Yeah, and one of the things about IAM roles is you can set them up, I think, both for people like within your own organization who are creating like the web app or the video game in AWS, but also for users of your web app and web game. You still use the IAM, AWS Identity and Access Management. You still use the same service to manage both your internal user policy and your external user policy, like your programmer user policy and your customers policy for the different web apps. And then you just assign different permissions based on who they are. So for example, like your programmers might not have access to a user's data because you don't really want like anyone in your organization to see that user's personal information. So you only give permission to that end user to be allowed to access their personal information. That kind of like protects their personal details, not just from outside external users, but also from inside your own organization.
Let's look at an IAM policy example. Unlike bucket policies, IAM policy does not require a principal element because the principal is by default the entity that the IAM policy is attached to. The first part of the policy specifies bucket level permissions. It allows the list bucket action so that applications can list all objects in the test bucket. The second part specifies object level permissions. It allows put object, get object, and delete object actions so that applications can write, read, and delete any objects in the test bucket.
Welcome to an
Let's have a look at the
overview of
models.
the types of cloud computing models. There are three main cloud computing models. First, let's look at infrastructure as a service. Infrastructure as a service contains the basic building blocks for cloud IT and typically provide access to data storage space, compute services, virtual or on dedicated hardware, and networking features. It offers you the most control over IT resources, trading off convenience, instead of building it all by yourself. You can also simplify provisioning and management by modeling your cloud infrastructure with a simple text file or programming languages and use as a template. Our resources needed for your applications can then be provisioned and configured based on your template automatically. This offers convenience to build your cloud environment. Platform as a service. Platform as a service removes the need for organizations to manage the underlying infrastructure platform and allow you to focus on the deployment and management of your applications. This helps you be more efficient, as you don't need to worry about resource procurement, capacity planning, software maintenance, patching, or any of the other undifferentiated heavy lifting involved in running your application. Here are some examples. To deploy your application, all you need to do is to upload your application code. Your application will be ready to use within minutes. In this example, you can still retain control over the resources powering your application and can access the underlying resources. You can also run containers without having to manage servers or clusters. All you have to do is package your application code and runtime into a container, and then simply deploy your container to the cloud underlying platform. Provisioning and management will be handled for you. In addition, you can run code without provisioning or managing servers. All you need to do is to upload your code or function. In this case, you do not have control of the underlying infrastructure. The service provides you the convenience of taking care of everything required to run and scale your code with high availability. Software as a service. Software as a service offers you end-user applications. You do not have to think about how the service is maintained or how the underlying infrastructure is managed. All the heavy lifting work is done for you behind the scenes. A common example of a SaaS application is web-based email, where you can send and receive email without having to manage feature additions to the email product or maintaining the servers and operating systems that the email program is running on. Here is a comparison between the level of control and convenience within the three cloud computing models. Software as a service provides you with the highest level of convenience, as you are just using the end-user applications. As you move from infrastructure as a service to software as a service, your level of convenience increases. Infrastructure as a service provides you the most control of your IT resources. As you move from software as a service to infrastructure as a service, your level of control increases. Welcome to types of cloud computing deployment models. There are three types of cloud computing deployment models: on-premises, cloud, and hybrid. On-premises deployment model is the same as the legacy IT infrastructure. Physical servers, databases, applications, and storage are located in their own facilities. Applications are deployed and run on these physical servers. On-premises deployment does not provide many of the benefits of cloud computing, but it's sometimes sought for its ability to provide dedicated resources. Cloud deployment model. In the cloud model, IT resources and applications are migrated from existing infrastructure to the cloud. Physical servers are replaced by scalable virtual servers. A cloud-based application is fully deployed in the cloud and all parts of the application run in the cloud, taking advantage of the benefits of cloud computing. Hybrid cloud deployment model. Hybrid cloud is a mixture of cloud and on-premises computing. The existing on-premises infrastructure can satisfy your need for control, latency, and sensitive data security requirements, while connecting cloud resources to your internal systems. At the same time, you can extend your existing infrastructure and grow to the cloud. Each type of cloud computing model and deployment method provides you with different levels of control, flexibility, and management. Understanding their differences can help you decide what set of services is right for your needs.
Cool. Alright, now we get to the plan. This is the plan section. It details the building activities that are required for the solution. Here we'll review the tasks you must complete in practice in DIY sections. The eye-shaped icon is a toggle that details the practice goals and highlights the portion of the solution that is built using guided steps. Click it. Create an S3 bucket. Configure S3 bucket web hosting. Upload lab files to S3 bucket. Rename index.html to waves.html. Wait, I didn't even get what we did there. Okay. Right, we're going to the next step. Alright. Logging into AWS console. Cool. Cool, this is good. This looks like how AWS looks. And now do they want us to actually review the lab objects sequence of Start Lab, then click Open AWS console to begin. Please follow the lab instructions carefully. Use the arrows below to navigate between steps. In this lab, you'll create an S3 bucket, enable static web hosting, and secure an Amazon S3 bucket using a bucket policy. Cool, this is good. So yeah, it's not just going to be inside this WebGL tab. You're going to actually open the AWS user interface and use it like you would if you're creating your own website. Okay, let's go to the next step then. Click Scalable Storage in the Cloud, S3. One. Review. Region. Drop down at the top right, ensure it's set to North Virginia. Okay. Yep, set to North Virginia. 2. In the services search field, type S3. Easy. Click it. What is what to do? Yeah, click S3. Go to the next steps. Wait. Go to the next step. I think we might need to double click this. It's not really clicking over. Cloud, click create bucket. Yep. Create bucket. Go to next steps. Type a new unique name for your bucket. Lab unique name 123. So it seems like we could call it whatever we want to call it. Let's call it wave height. Yeah, just call it wave height. Website. Wave height website. So we're going to have the web pages in there. Choose US East 1. Scroll down to the page. Yep. To next step. Or Amazon S3 bucket names are globally unique, and the namespace is shared by all AWS accounts. That's interesting. So you need to make sure you have like a very unique name for your bucket, because yeah, it needs it like literally not just within your own account, but in all accounts it needs to be unique. In the object ownership section, choose ACLs enabled. Okay. Objects in the bucket can be owned by other AWS accounts. Access to this bucket and its objects can be specified using ACLs. ACLs disabled. All objects in this bucket are owned by this account. Access to this bucket and its object is specified using only policies. I don't know the difference between policies and ACLs, but I guess we're going to find out. Wait, what do we choose? Object writer. Bucket owner preferred. If new objects written into this bucket specify the bucket owner full control canned ACL, they are owned by the bucket owner. Otherwise, they're owned by the object writer. The object writer remains the owner. remains the object owner. Interesting. I wonder if this is good for different users who are all writing to the one bucket, and that just makes them automatically own their own resources. I really got no idea. But that's what we're here to find out. Blocking public access settings for this bucket. Public access is granted to buckets and objects through access controllers. Bucket policies, access point policies, or all in order to ensure that public access to this bucket and its object is blocked. Turn on block all public access. These settings apply only to the bucket and its access points. AWS recommends that you turn on block all public access. Before applying any of these settings, ensure that your applications will work correctly without public access. If you require some level of public access to this bucket or objects within, you can customize the individual settings below to suit your specific storage use cases. So we're blocking all public access. Oh no, we've got to unblock public access. Turning off block or public access result in the bucket objects within becoming public. Yep. So we want people to see it because there's a website that we want people to come and visit. And if it's not public, they won't be able to see the website. Bucket versioning. Oh no, I'll finish this bit, go to the next. Okay, what's the next thing? Scroll down to the bottom of the page, and now we're going to create the bucket. Oh, we're not allowed to contain upper letters. Let's try Wayflight website with all lowercase letters. Cool. And we've got our Wayflight website bucket here. Next. Let's view these details. Sure, you could click this unique bucket name if you wanted to see it as well, if you accidentally click the cross. Alright, gotta upload some stuff. Click upload. Navigate back to the game, then click the Lab Files tab. How are we going to do that? We're stuck in this tutorial. Oh, here it is, up here, Lab Files. Click the download icon next to the file to save the files and go to the next step. Okay. Huh, interesting. We have to actually download onto our computer. Create a new folder for the moment. Not in here though. Create a new one on our desktop for the moment called AWS Cloud Quest. Chuck it in there. There. Cool, so we've got an index.html file, a main.js file, style.cs file, and target file.csv. Cool, so we've got a little app coming together. Some next steps. Add files. Let's go to that folder that we just created. Desktop. We just do all these in one go. Yep. So they're loaded. Go to next steps. Quick upload. Let's see what type of files they are. Interesting, the CSV is put as an Excel file. I've got text.csv there. But mine is application Excel. Well, it shouldn't really matter. It's not like just how it's categorizing the file type. It's weird that they got it different to mine though. In Windows, you may see a blinking notification menu bar. Click all files you previously did. Click upload. Did we do this already? It is. Go down to static website hosting and click edit. And then I guess we're going to enable, just check. Enable, oh yeah, other things are going to come up. And we want to host a static website. In the index document, type index.html. That's kind of like, where does your website begin at? It will begin at the index. Amazon supports two types of URLs, virtual hosted style. And then save changes. Permissions tab. Review the block public access. Make sure it's off. Yeah, it's off. Scroll to the bucket policy section. Where's that? Yeah, just a bit lower. Click edit. Click the icon to open up your buckets ARN. That's some kind of reference number. Delete the content in the policy. Edit a section. Gone. Quick policy generator. It's Amazon resource name ARN. Both use JSON-based access policy language. In the select type of field policy, choose S3 bucket policy. This is good, so you don't need to really have to know JSON. It's going to set it up for us with this drop down, which makes it easier. We want an S3 bucket policy. In principal field type asterisk. Action field, choose get object. Get object. And I guess we're going to put our ARN. Then apparently we have to add something to the end of it. / and a star. Oh, so that's like / is for like folders contained within the bucket, and the star will be like any of the folders. We've got the bucket, but then we're going to have other files or folders. Should say files probably. So we've got an object policy. We're allowing people to grab something, and it's any of those things. And click add statement. View the parameters. So they should have access, they should be able to get any of the objects out of the bucket. But then I'm not sure what this principles is for. Let's go back and see if it gives us some info. AWS Policy Generator enables you to create policies that control access to AWS products and resources. Policies are comprised of statements. An effect statement will allow or deny an action by a resource. An action statement will define specific operations for a resource that can be allowed or denied using keywords. So yeah, this is like what they can do in actions, but principle isn't really explained what the principle is. Maybe it's like who can use this, I'm not sure. Does asterisk mean any bucket can use this? So of course asterisk is the wild card character for any value. That's where we're up to. Oh, here we go. In a bucket policy, the principal is the recipient, e.g. user / or account of your configured permissions. Yeah, so it's like who. For bucket policies, buckets and objects are the Amazon S3 resources for which you grant, allow, or deny permissions. The Amazon resource name is the resource identity. Principals an account, user, service, or other entity which is granted access to the actions and resources in a statement. Yeah, so we're just saying, using that wildcard for anything. We're saying anything or anyone can have access to this resource policy. For example, this bucket can use it, or a different bucket could use it, I think. Not really sure. Copy the generated policy. Go to next steps. Okay. Generate policy. Interesting that we've got to copy it. That just doesn't automatically upload. But then we go to here, paste it in. And we've got our bucket policy. Statement SID, this, action S3 get object, effect allow, resource is this, principal this. Wonder if you can edit this policy automatically as you're adding new resources or something like that. Return to it. Scroll down to the bottom of the page and go to next steps. And next steps. Oh, I mean, save. It's got this. Properties. Scroll to static website hosting. Next steps. Review the settings to verify that bucket hosting is listed under hosting type. Yep. On the top of page. Next steps. Open a new window or browser tab and paste your S3 bucket website and point you copied into the address bar. Oh, did we miss a step? Yeah, we didn't copy this. Copy that. Now we're going to open a new tab. should see the website. Let's give it a go. Cool. That's awesome. We can see how big the waves are going to be now. Congratulations, you finished the first part of the solution. Go to the DIY section to complete the solution. Rename the index.html to waves.html. So if we validate it without doing it, let's see, is it gonna work? No, can't find any URL at any possible input. Okay. Now, see if we can do that. So let's see what objects we have. Got this index.html. Is there a chance for us to rename it here? Object actions. Rename object. Called waves.html. Okay. You can see it's waves.html. Let's validate it. Maybe we need to type it in here. We call it waves.html. Yes, it is waves.html. Why didn't it validate? It seems like we can't put anything in here either. Oh, yes, we can. Okay. It's just the user interface. Does it work? Because you'd expect that to start when you click on it. You expect to see that the line go in there that shows you can type, but it's not there. Okay, so I guess we got to get the full endpoint. Does it give us the endpoint in here? The S3 URI. Is it the S3 URI or the object URL we want? Like the object URL, that's HTTP as the example. Good. Oh, we can click there to copy. Let's try validate that now. Cool. Excellent. Complete. Oh, that's the mayor we're talking to. We're quite high profile, speaking to the mayor straight up. Hey mayor, thanks for providing a quick and simple solution. No worries. Do we rate that as quick and simple? Yeah. Like, I mean, it wasn't too bad. You are welcome. It looks like, I wouldn't say it was simple though. If we didn't have the tutorial, it'd be pretty bloody hard, which is why they've built this game for it. So saying it's quick and simple is a bit far-fetched, but we all do that when we advertise our products. We say they're quick and simple, but they can run into a few hiccups along the way. You're welcome. It looks like the beach crowd is returning. Yes, the beach is back. I'm thinking of adding a lighthouse to the pier. Please help me choose the style. Cool. We get to pick which one we want. Very stripy, a little bit stripy, only one stripe. They all look good, but I think I like the only one stripe. We get our reward. Our reward is the power to choose how many stripes the lighthouse will have. Stuff like this is like the mayor's just general thoughts, like, oh, we've got people coming to the beach, let's add a lighthouse. Like, because he thought of it. I'm thinking of adding a lighthouse to the pier. Surely that's got more to do with the safety of boats than just for fun, adding a lighthouse. Or doesn't want us to collect our lighthouse though, this is kind of stalled. Damn, just when we thought we were doing so well. I'll have to try to reset this. Wonder where it's going to drop us in. Cool, we completed it. Got 8% of our way to becoming a cloud practitioner. Oh, it's weird that like right click changes camera view. Left clicks to walk. Okay. Is he going to talk to us now? No. There. Got a new assignment. Look for cloud first steps on the assignment list. Complete 2 assignments to unlock pet friends. Cool. Well, I'm happy to leave it there for the moment. We did our first assignment, which was to create a website that was hosted in an S3 bucket. And we did it. Well, yeah, I think it's pretty good. Like, it kind of gives you a fun way to do a tutorial on AWS. Makes it a bit more exciting than at the moment reading through the documentation. So do I think that this could help people to learn how to build apps in AWS? Yeah, I think it definitely can. It's pretty much a more fun tutorial. Everything's still step by step, really set out really well. So if it allows people to just get their hands onto the game, it's even like a game, but onto the AWS website and start using it in a fun way, rather than just reading through a bunch of notes. Does it make it any faster to learn? I would say the actual process isn't sped up at all. It's still the same steps that you'll be doing if you did any other tutorial. And even probably a bit longer because you've got all these different things in between. So in terms of the actual process, I don't think it makes it faster. But in terms of someone doing this in terms of their life, well, I think, yeah, this will encourage people to want to progress to the next tutorial faster and learn more to get like your rewards of the lighthouse and stuff like that. So even though the process of learning about AWS isn't sped up, just the rate of engagement of users will be increased. So people will probably come here more often to learn about AWS web services, and by doing that, the overall journey in building web apps would be sped up. So could this be used for professionals. If they want to, they've probably got enough resources already. If they don't want to, I wouldn't say it's a necessity. Could it be used for education? I mean, high school, you could definitely do a kind of, you could definitely do like a unit of work around this if it was like some information technology course or something like that. University, you wouldn't really have it as a university course, but if you're a student, you could definitely use this to accompany your university course as like an extra like practical you could do. Maybe even if it was some kind of course to do with web services, microservices or something, you could use it as a practical tutorial, but still then it's a little bit basic. It will have to definitely be like a real introductory course, maybe like a first year course. But even for a first year course, this might be seen as a bit basic. But we've only done the first one so far, so we'll see what the other ones are going to be like. It could get a bit trickier as we go. But for there, we'll leave it for there. And next time, we're going to have to help this person with emergency. Have an excellent afternoon. Hopefully that gives you an insight into AWS Cloud Quest. And if you want to view it, just search it to Google AWS Cloud Quest and jump on and give the app a go yourself. Let us know what you think about it once you've given it a go in the comments below. Have a good day, guys. Bye.